Moving on to the next session, Mr. Krish Theobald is the speaker of this session. He has a great expertise in UK's national wiring regulations. He is a technical director at Protego Plus Electrotech Private Limited. He is currently a member of Institute of Engineering and Technology, UK. The session is on the topic Selection and Erection of Wires, Wiring and Protective Devices. The key to the successful operation of wire system is to select the most suitable wire for the application, make a correct installation, and perform the required maintenance. In this technical session, we will learn in-depth information about the appropriate wire selection and application for power distribution and utilization. Now, I request the speaker, Mr. Krish Theobald, to take us on the topic. The podium is all yours, sir. Thank you.
Okay, hi, morning everyone. Thank you for the introduction. So before we begin, I do realize that this is going to be a very lengthy presentation and it is quite technical. So yesterday, like Mr. Gopakumar mentioned, it would be very helpful if you have a copy of the National Electrical Code SP30. I know a gentleman here has actually carried it, and IS 732 as well. So for a show of hands, how many of you have either a digital copy right now or a physical copy of the NEC? Okay, wonderful, because you've taken the first step towards taking something beyond this conference, because you're going to actually need to apply it later on. So thank you for that. So before I get into the actual presentation, I'll just go over what section 5.2 of IS 732 covers. Basically, we're looking at the actual cables and the conductors we're using, any terminations and jointing in it, so that's kind of lugs, crimps, etc. Supports and suspensions, so you can see the supports and suspensions, and actual enclosures or methods of protecting against external influences. So this presentation has been broken down into 6 parts. I believe we're going to take a break in between. So so firstly we'll look at wiring system basics, then protection with relation to external influences, cable sizing, the electrical connections and terminations, wiring systems for fire safety. This was already covered by Mr. Gopakumar yesterday, so we're going to just breeze pass through this. And if there are any other considerations, a lot of which Mr. Apu has already covered today with regards to EMI. So as you can see, each section has a reference to IS 732 or NEC at the top. So if you have a question relating to any of these, anything I'm speaking, please note down the regulation number. And at the end of each section, there is a review slide where I'll take questions regarding that specific topic. So are we clear on that? Thank you. Right. So when we look at wiring system basics, there are 6 basic things. We'll just look at common wiring systems, like armored cable being one of them. How we should install cables, some do's and don'ts, how circuits are arranged, any special considerations for multiple circuits being arranged together. What happens when we get circuits to enter ferromagnetic enclosures like our distribution boards, and how do we prevent something called premature collapse. So common wiring systems are recognized by clause 5.2.4.6 and in clause 5.3, 5.9, 5.10, and 5.11 of Part 1, Section 9 of the National Electric Code are, I'm not going to say the regulation this time, but so you've got conduit, which is covered by the IEC 61386 series. Note, a lot of these IS standards exist, but they're very old. So for the purpose of the presentation, I have made reference to IEC standards, but please, when you go back on Manak Online, a lot of these are now IS/IEC. They're just a standard that's directly been approved as IS. So if you put these numbers in, you'll find the relevant IS standard and you can check for conformity with that manufacturer. And it's very important for the actual products that we select to actually meet these requirements, because that's the only way we can achieve the overall performance requirements mentioned in IS 732 and SP30. Now, classic example is I was consulting on a site in Mumbai, and they had already run all the trunking before I was involved. So I said, what is the trunking that you have used, what's the brand? And the electrical contractor said Jindal. Now, Jindal is an aluminum manufacturer. They're not actually, they don't have the necessary equipment and they don't run the necessary tests to prove their sections as trunking. So there's no ways that that installation could actually comply with IS 732 or SP30. And like Mr. Gopakumar mentioned, then you're non-compliant. So conduit is the 61386 series, ducting and trunking, which is here, is the 61084 series. You've got cable tray and cable ladders, which is the 61537 series. Cleats, which is the 61914 series. And then you have two slightly different methods of wiring that don't involve actual wires for the distribution, which is bus bar trunking, which is 61439 part 6, and you've also got to comply with part 1 for the general, and power track, which is the 61514 series. So how do we install our cables? When you have single insulated cable, which is pretty common in India, which is just the, you run red, yellow, and green and yellow. Those are single insulated cables, and these need to be completely enclosed throughout their run. So it's very often we see that cables are installed in conduit, but just when you bring it to the junction box, you just leave the cable and there's an enclosure. Often the hole is bigger or the hole is massive, and then you immediately compromise the IP rating and you don't comply with section 4.2 of IS 732, which is protection against electric shock, because you have single insulated cables that are available to touch. Remember that power pyramid from yesterday? You're only achieving basic protection. The other 3 layers, gone. So you need to have proper glands and fittings here for your conduit, and this is an IP rated enclosure. That way you're maintaining the IP rating. And these will obviously conform with the 61386 series. Now, if you have trunking or ducting, they need to, like we mentioned, 61084 is the IC standard. And it's very important that if you're using single insulated cables, they need to meet a minimum degree of protection of IP4X. So an IP33 ducting cannot be used with single insulated cables because that doesn't contribute to the first 2 layers. It's not basic plus fault protection. And obviously it has to be earthed, which is a different story. And if it's not earthed, there are other considerations. Also, the cover should not be just able to come off. Oftentimes I've seen you go into a doctor's waiting office and they're very poorly installed electrical work. And a child or somebody who will just go and sit there and start fidgeting with the trunking or the ducting, the entire casing, the top will just come off. And then immediately you have, sometimes they put connections also inside, like they twist cables and all, which is a terrible thing. So this should only be removed by a means of a tool or a very deliberate action. Like in the case of trunking, you snap it upwards and pull it out. So things like the using of glands, bushing, are very important topics. In fact, I had met with a very large manufacturer of steel conduit, and they said, we don't manufacture bushing. So I said, how are you going to then terminate your steel conduit inside an enclosure? Just leave it there? You need a brass bush to go inside and then have a coupler connect to it. That's the only way you can maintain the IP rating. Now, circuit arrangements. How many of you guys have seen line, neutral, and earth conductors run through separate conduits for the same circuit? No, not a lot. Well, I do, some of you have. So I do quite a lot of work with domestics, and a lot of high net worth individuals have this problem. I was at a site in Hyderabad. The electrician ran the line and neutral through the conduit and then forgot about the earth. Something happened, his audio-visual equipment worth some couple lakhs blew up, and he said, no, we need earthing. So what did he do? On the wall, he took some tape and he taped an earth cable. It was red color also, which is a complete wrong, but the biggest thing is they run through separate systems. Now, junction boxes, very often they just tape the connectors together, leave it in the trunking. No. A junction box has to comply with the relevant IEC standard 60670, and part 22 is the requirement for connecting assemblies, because the standard covers a lot of other enclosures. Then, if a junction box has 2 or more circuits of different phases, there should be no possibility of confusion. This is a should, by the way, it's a recommendation from my side. Because at the end of the day, from a maintainability point of view, which is a fundamental principle of 732 and SP30, this needs to be considered. So it has to be labeled as per, and 514 goes into labeling. Please do not distribute the conductors or different systems. And very important, this was something that was shared in the NFE group, is a final circuit shall not share neutrals, okay? You cannot have one socket and then one lighting circuit, and then one washing machine circuit, all of them sharing one neutral. In fact, you cannot even have a socket and a light circuit sharing one neutral. Line and neutral for each circuit have to be separate, and in most situations, even the earth conductor has to be run separately from a single point of earthing. Okay, now what happens if multiple circuits are being run together? Most often, you're going to have multiple circuits. Let's say for this very conference room, there's a main distribution board somewhere, and there's a sub-distribution board here. And for the top, you've got lighting circuits, some air conditioning circuits, whatever. So it's very common to run multiple circuits together. Now, obviously, cables are going to heat up when electricity passes through them. And then you need to rely on the fact that this heat is going to then dissipate, and that's how you get a current carrying capacity of a cable. But if you have multiple cables grouped together, like in this image, obviously, do all of you agree that there's going to be a thermal effect of this? Yes? Exactly, which is why Annex S of IS 732 and part of Section 9 in SP 30 goes into derating factors. So if you're running multiple cables together, let's say 2 circuits, 3 circuits, you're going to have to use a reduced current carrying capacity. We'll go into the factors slightly later on in the presentation. Additionally, if a cable has more than 3 loaded cores, so again, when it comes to harmonics, there was a gentleman on the NFE group who was saying that let us use a 5-core cable and let's have 2 neutral conductors. Not a very conventional idea, but I'm not saying that it is wrong. Maybe from other points of view, it is not a very good, it is probably even non-compliant. But if you're going to do that, you need to realize that then 5 conductors are going to have current flowing through them. And as per Annex S and IS 694, IS 7098, all these standards give current carrying capacity for 3 loaded conductors for 3-phase, because they are assuming the neutral will carry no current, and 2 loaded conductors for single-phase cable. So again, you have to derate. In the case of 5 conductors, the factor is 0.72. So 0.72. So only 72% of the current carrying capacity can be utilized. Also, for some reason, it's a control circuit. You will run multiple cores in one cable. Let's say 11 core or 14 core. Then obviously, and you have voltages of different bands for these circuits, then the cables must be insulated for the highest voltage. And there should be a single isolating device to cut off supply to all the cores in that cable, because from a maintainability point of view, that is otherwise a hazard to your technicians. Ferromagnetic enclosures. Now this is an interesting one. We've all seen the meter board, we've all seen distribution boards and things like this where you have cable entering through. I'm sure we have, right? But did you know that if this is actually an image that a friend of mine, David Watts in the UK, shared. You've got 2 parallel conductors for L1, L2, and L3. And between L1, L2, and L3, there is a ferromagnetic enclosure. And see what's happening there. Is it visible to all? It's heating up. That's the eddy currents. Basic stuff we learned in college, right? So if they enter, all the conductors, line 1, line 2, line 3, and neutral, and protective earth must enter through a single cavity. And they must only be correctively surrounded by such material. Otherwise, you're going to have eddy currents. And if you have steel cable cleats, you cannot use these on single core cables, because again, eddy currents. Additionally, if you have single core armored cable, you have to use aluminum armored cable, because aluminum is not ferromagnetic unlike steel, so this consideration is not a problem. And if it's a specialist application and you need to gland through multiple cables, you can simply use an aluminum gland plate, as then this is no longer a concern. Premature collapse is an interesting one, because per se it is not mentioned in 732. But if we look at 5.2.4.10 and the fundamental principles, which is that this wiring system shall be safe and not cause harm to any individual, we should ensure that the wiring system A must not be liable to premature collapse in case of a fire, and B should not collapse simply due to the weight of the cables itself. So this is an image that a friend of mine, Paul Meenan, has shared. Can you see what's happened there? The entire system has collapsed. Now, how many of you guys have installed screws on plastic wall plugs? I'm guilty here as well. How many of you guys have done that? Screws on plastic wall plugs, one person? Come on, I'm sure more of you guys have. Yeah, come on, thank you. This is completely inadequate from a premature collapse point of view. Plastic is a flammable material, and in a fire condition, plastic will melt and this will happen. As such, there is no IS or IEC standard for premature collapse yet. People are working. This is still in progress through a BS standard. But the basic idea is that an ETA approved anchor, such as a steel anchor, and so you get steel anchors and then you have ETA approved anchors should be used. And cast iron cable cleats, etc., complying with 61914 are a good idea. Usually the manufacturer will say that this can withstand excursion to 1000 degrees Celsius for 2 hours. That way we meet this requirement. So before we go on to the next section, does anybody have any questions on wiring systems and the basics? Sorry? Okay. Wiring accessories we'll get into a little ahead. So if you don't mind waiting, that comes in your connecting bits. So let's look at protection against external influences. You see this gland here? It's a decently installed gland, but it's just not rated for the external influences that are present. So firstly, we've got ambient temperature. Then we've got external heat sources. Water or humidity, it's a big one. Foreign solid bodies, dust, etc. Corrosive or polluting substances, such as even salt in the air. Vibration. Any other mechanical stresses? We've got flora or mold growth, fauna, which is animals, solar or UV radiation, seismic effects, movement of tectonic plates, wind, of course, the nature of process to store materials, which is if it's a factory, wood, stuff like that, and building design. So this is all to ensure the long life of an installation. You don't want to have to keep going back to the same installation again and again and performing maintenance work. I mean, I don't know about you guys, I really hate doing that. Maybe it's a source of constant revenue, but at the end of the day, the client is going to break their head and be like, why do you have to keep coming out to my installation? Can't you get it right the first time? RCD tripping is also very often caused by water getting into the cable and containment. If this is looked at, that can be greatly minimized. So let's look at these. So ambient temperature. So like I said, we all know that wiring systems emit heat. Now, the insulation on the cables are rated for a certain maximum operating temperature in continuous use. So the higher the ambient temperature, the lesser that gap. So Annex S assumes a 30-degree ambient temperature for thermoplastic cables, which is PVC cables, and a 90-degree limiting temperature for thermosetting cables, which is XLPE. But if our ambient temperature is 40 degrees, then the temperature rise available for the cable is lesser. So you then need to derate the cable. So it should be derated for the highest temperature possible. So let's say we are doing an installation in an area that can get hot in the summer and can get cold in the winter. You cannot say right now it is 25 degrees, so I'll take 25-degree current carrying capacity. You need to look at the overall utility. Limiting temperatures are adiabatics. So coming to adiabatics, usually this is 160 degrees Celsius for cable. That is in a fault condition how hot the cables get. And so we need to ensure that they do not exceed this temperature in a fault condition. Additionally, all the wires, accessories, junction boxes, and saddles should only be installed in temperatures limited by the manufacturer that there is some understanding in the market. But even handling and storage, you cannot leave your cables and cable cleats out in the sun. Like many times the electrician will come on site, someone calls them inside, they leave it there. Then immediately it's exceeded the limiting temperature and then it can no longer perform to the relevant manufacturing standard. External heat sources, this is an interesting image because you have a hot water pipe and you have a cable that is damaged by it simply because of the temperature of the cable. So they must be protected from external heat sources. I think yesterday one of the people that spoke about shielding and maintaining a sufficient distance, or simply if nothing is avoidable in, let's say, an industrial location, you need a wiring system which is suitable for that temperature rise. This is, as such, not the ways of creating protection against external heat sources is not mentioned in 732. There are some only recommendations. So any other equally effective method is compliant with IS 732. Then, some of these could be in our own homes. Like, how many of y'all have seen a geyser installed in a bathroom like this? I'm sure a lot of us, right? So the cable going through near the hot water pipe is going to get hot. And that cable is a flexible cable. It could even be rated for 60 degrees. So, and let's say the cable, hot water, let's say 40 degrees, you're only allowing 20-degree temperature rise. And most of the time, 40 degrees is the temperature we bathe at. Hot and cold water mix first. The hot water is going to be much hotter. So this is going to damage the cable. Even something like halogen lights. In fact, I was involved in a project once where a bathroom was being renovated. and they had to waterproof the floor, but it was the monsoon. So the contractor said, can you put a halogen light here to help heat it up? So some electrician came and put a halogen light. Later on, when I went on site, a circuit breaker had tripped. When I went in, I saw the halogen light melted the cables. So you need to think about all these things. If this again, and even sunlight is a big one here, because we think about sunlight as UV rays degrading insulation, but even constant exposure to sunlight will raise the operating temperature and could take temperatures beyond the insulation, what the temperature the cable could withstand. Water and high humidity. This is a very interesting image because you've got water that's come inside, and it's an image from North America actually, where they've got unsleeved earth conductors, and they use steel for some circuits, and the corrosion has spread from the enclosure and gone to the neutral link. I've actually seen this happen in India as well. And now this has corroded, the impedance is going to be through the roof. When a short circuit or fault happens, you can guarantee that the circuit breaker will not trip. So how do we protect against this? See, there are IP ratings as per 60529, and depending on the nature of water, whether it is a small amount of water, there are droplets, immersion, submersion, etc., there are IP ratings, these have to be selected. If water is going to be collected, let's say it is near a marina or something like this, it is very important that there are ways for the water to escape. I met with a manufacturer 2 weeks ago. A gentleman came to my office to talk to me about their glands, and they actually have a gland rated for, it is manufactured specifically for the purpose of allowing water that is collected inside enclosures to escape. Also, like I said, corrosion is an important thing. Excuse me. A lot of times, you need a robust system like steel for conduits, but steel is not going to react with water very well. Galvanizing is one option which also comes off, but using simple things like polyamide coated steel conduits, there are a lot of manufacturers in India that manufacture this, means you don't have to worry about this. Obviously, if you have wave jets splashing, immersion or even submersion, like in swimming pools, there are special considerations simply because of the massive volume of water and even the mechanical damage caused by things like waves. Again, this is probably best to consult with the manufacturer of the cable for the containment system for this. So solid foreign bodies. This is again an image. You've got a massive amount of dust that's collected in here. This is going to go to your terminals. The impedances are going to increase, and this is going to cause a problem from a short circuit point of view. If a short circuit happens, your device might not trip. And these circuit breakers usually only are rated for a certain level of they're only rated for use with a certain level of pollution in the atmosphere or a certain level of foreign bodies. If you look at their manufacturing, the catalogs, you'll see this information there. So again, the IP rating comes into place here. So as you know, when you have IP ratings, you have two numbers. The first number is protection for solid foreign bodies. The second number is for water ingress. So you can look at 60529 for this. So again, special considerations must be taken. Again, if the dust is going to accumulate, and this is going to then limit heat dissipation. Say you have a vent, and the dust accumulates in the vent of the panel. As yesterday, a gentleman spoke about panels overheating. So if the dust is going to accumulate in the vent, you must make sure that this dust does not affect the heat dissipation characteristics. So again, this is a good idea to consult with your manufacturers for this. A lot of manufacturers for good panels will gladly help you with this. Additionally, if the accumulation of these foreign bodies can cause pollution, especially when you've got the presence of water, this is a very bad combination, and again, you should consult with the manufacturer for this. Corrosive or polluting substances, like I said, could be something as simple as salt in the air. This is in Alibag, a coastal area near Mumbai. This is the main panel of the gentleman's house. So there is no bottom left, there is no lower left on the side, and everything is very badly corroding. You can see the ultraviolet light has even badly damaged some of the insulation there. So these need to be resistant for corrosion caused by foreseeable corrosive or polluting material, including something as simple as water. Simple things like polyamide coated steel or stainless steel SS316 would work here. Another thing is dissimilar metals. So a lot of you are aware, I'm sure, that you have copper cables and aluminum cables. Now, most terminals on equipment or terminal blocks are brass or copper, some sort of copper alloy. So it's very important that the anti-corrosive compound is applied, which prevents the oxidation of the aluminum. Because if you have dissimilar metals, the electrons will jump from one metal to the other, which will cause corrosion. I saw a bad case of this in Hyderabad once, where an entire bolt had rusted. And then that guy's impedance in his house was 20 ohms from line to neutral. So again, this is a simple thing. You just look at the manufacturers that make this anti-corrosive material. You follow the manufacturer's instructions for the termination of aluminum cables or the copper cable lugs for use with aluminum cables, and you're good to go. Another interesting thing is we're starting to see a lot of modular homes and construction in India where you've got thermal insulation. They don't use brick walls. They use an aluminum partition. Then to create sound insulation for the purposes of sound, or in case of colder areas, even heat, you have thermal insulation inside. Very often, this thermal insulation, when it comes into contact with PVC insulation, will cause a degradation in the PVC insulation. Then your insulation resistance goes down, and as you know, that's cause for concern. Impact. So this is actually an unfortunate incident where I was there. An electrician drilled through a cable, and fortunately there was a circuit breaker that was tested and everything was fine, so no actual hazard occurred because of it. But you can see what drilling through a cable does. It completely destroys the cable. It was also fortunately an accessible cable, so you could pull it out without any problem. So impact, penetration, or even tension, and especially during storage as well, is an important consideration. Now IEC 62262 and 60668 part 2 subpart 75 actually talk about something called IK ratings, similar to IP ratings. These are containment or conduit rated for a certain resistance to impact under specified test conditions. So if we know that impact is going to be an issue, it is always preferable to use a system that is rated for, that has IK performance ratings. Or additional local protective measures may be used. I'll show you here in the next slide. So this is a very common arrangement, again, these modular homes where you've got wooden or aluminum panels, and you've got a floor here and a roof. This is your roof, this is your gypsum from the previous floor, and this is your current floor. So here you have a metal pipe that is put, an earth metallic conduit to 61386 part 21. And then, or you have to make the hole 50 millimeters from the top or the bottom. Again, assuring the structural integrity is not affected. Or you can use a metal plate like this that will prevent damage. So this may be achieved by using an earth metallic conduit. It can be achieved by using earth metallic trunking. So 61084 part 2 part 1 is for trunking in ducts for walls and ceilings, and 61084 part 2 is for trunking and ducting in floors. Or the cable could be part of a cell or PEL circuit. This is again a may, so this risk must be considered. Or if you just use an RCD for concealed cables, this risk is also much lower. Vibration. Please do not take this image as an example of how to earth systems. This is very poorly protected against water and dust. But the reason I showed this image was for the coil of cables. Very often when you have things in areas that are prone to vibration, especially due to machinery, or even if it's an RCC, you have wiring concealed in an RCC, this is going to be liable to vibration. By coiling the cable like this, it gives the system flexibility to withstand these vibrations. And especially for medium or severe or high vibrations, this must be considered. And if you remember from yesterday, must be considered means you have to do it or take a protective measure you have to find another equivalent protective measure that gives the same degree of safety. Now, flexible cables may need to be used in applications like this, and only in applications like this, because let's say you have a suspended luminaire, let's say a hanging light, you cannot use a rigid cable. That thing is not going to be able to withstand the movement due to the air. This is an interesting one, mechanical stresses. So when you pull cable through conduit and when you bend cable as part of an installation, there is actually a radius of bend that the manufacturer allows. So if you look at this image here, when you bend a cable, the internal turn is compressed and the external turn goes through tension. So obviously there is a big mechanical stress here. So usually the manufacturer will provide a maximum bending radius, and the radius is calculated as, if this is the diameter, a multiple of the diameter is the radius of the circle you are allowed to bend by. So, and if the information is not presented, you should probably find another manufacturer, or For cables less than or equal to 10 millimeter, the bending factor is 3, 10 to 10, this should be 10 to 25, sorry. It is 4, and 25 onwards it is 6. And this applies for containment as well as just clip direct. Now, every cable, conductor and terminations need to be supported by adequate mechanical and electrical equipment. So usually your M&E manufacturer will give you, do a load calculation for you free of cost. I know Hilti does one. And it needs to be considered that there should be no damage by their own weight. Additionally, if you have single core cables that are being run that are greater than 50 square millimeters, depending on some applications, due to a short circuit happening, there are some electrodynamic forces that are in these conductors, and they will have a mechanical, you can see the mechanical effect of that. So the M&E equipment has to be rated for withstanding that as well. Now, how many of you all have seen conduit and trunking with cables shoved through them? Tons of cables. Not a lot of you. Well, you're lucky maybe. I've seen a lot of these. I've seen 12 cables drawn through a 20 mm conduit. When you open it up, inside is completely destroyed. So as a rule of thumb, for conduit with multiple cables, only 40% of the internal cross-sectional area shall be filled. And for ducting, it is 45. There is further guidance on this in section 9, part 1 of SP 30, clause 5.4.9, which allows slightly greater, you can fill the conduit and ducting to slightly greater percentages depending on the type of cable. Please refer to that. So we went through this, and by the way, these are only valid for straight runs of less than 3 millimeters with no bend. The moment you introduce a bend, from a pulling point of view, you are introducing further mechanical stresses. So then you need to look at the manufacturer information. They will usually provide this. Now, other mechanical stresses, there are more. So if you have a wiring system that penetrates a load-bearing element, such as a column or beam, firstly, you must make sure you can do that. So you must consult with a civil engineer or other competent person. And then even just inside walls, the ducting and conduit systems need to be fully erected before you put the wiring through. I have not seen any electrician that actually does this. They all run the cable while they put the conduit and then they pull it. The reason for this is A, you are more susceptible to mechanical damage when you do it together, and B, chalo, you put the cables inside and you're done. How are you going to contain maintenance if you want to make any additions, alterations? That cable is just not going to come out. So this wiring system, the conduit or ducting needs to be designed keeping in mind this maintainability and serviceability so that the installation is useful over its life. You can't break the thing again, you can't break open the floor and the wall to perform maintenance or additions. So that's quite important. And expansion joints, again, you need to make sure that any stresses on the expansion joint, such as expansion or contraction, does not cause wiring damage to the system or even their terminations. Now, if you put wiring through a underground passage, you must make sure that, firstly let's talk about soil. So you can see in the image here, you've got cables that are laid underground, and you need to put some sort of tape on top of it and then cover it up. The reason is, let's say there's further civil work or further some work by some utility provider. The moment they see this, they will realize, okay, we have cables underneath. Because a lot of times, these people are not going to have access to your drawings, and ideally they should, but if they don't have access to your drawings and show where the plans are, and plans that show where the cables are, this is a clear indicator that there's a cable underneath. Additionally, if you have underfloor systems in, say, a factory where you have a forklift operating, you need to make sure that it can withstand the impact of the forklift operating on top. You need to talk to the manufacturer about this. Additionally, if you're burying cables in the underground, in soil, you need to use a conduit or duct with an appropriate IP rating, and the enclosure of the duct or conduit needs to be able to act as a protective conductor, just like an armored cable, or you may use an armored cable instead. This is to provide fault protection. Flora mold growth is a big one. So this is an image of some underground cable, and the root of a tree has gone over and damaged the insulation, causing a fault. So you need to make sure that, either you maintain a suitable distance or you use a conduit or duct with special protective coating. Now, if this is a big external influence, let's say you are in an area with a lot of agricultural work and a lot of plants, then certain pest control and cleaning will be required. and it must be ensured that the chemicals used for this do not have a detrimental impact on the wiring system. Very often air conditioner people will come and they will use some chemical to scrub their air conditioners, and these will leak on the ducts and trunking. What happens is this is not clean, and then slowly it corrodes the finish on the duct or trunking, especially in the case of galvanized finishes, and then corrosion happens. Fauna, so you know, an animal coming, rodents coming and eating up wires. So actually last year in about August, I had a guy in Alibag who said that I keep losing power to some of my outdoor lights, and he had like a spa that was outside his bungalow because rats keep chewing up my cables. So then I spoke to a conduit manufacturer, and they said that why don't you use steel cables that are coated in polyamide, flexible steel, flexible steel conduit coated in polyamide. That way the rats cannot possibly go through the steel. Or you simply install them out of reach of such animals. Again, you will need to consult with the client and the wiring system manufacturer to understand where exactly these external influences are present. And again, any chemicals or pest control substances should not have a detrimental impact on the wiring systems. Oh yeah, absolutely.
So how do you manage that? Because that's not even how it enters and it starts biting everything, including the strands coming out.
So within a product itself, I cannot comment because that would be covered by the product standard. As a consumer, you would have to take some protective measures against it. I'm not the right person to answer that question. But see, the basic idea is that if cables are used anywhere in locations where this is a problem, you must take some protective measure against it, such as putting it in conduits. Like I said, for products, I am not the right person.
Not necessarily, actually in the whole automobile, our cars, bottom cars, wires are being cut, and the washing machine, the bottom wires, it's a wire, it's not a cable. There's like a thin wire, like 1.5, 2.5 square wires, right? So these are all it cuts and breaks it. So it is happening in our home appliances where these rodents enter some way, it enters and damages the wires.
So are you talking about the cord that connects the appliance to the socket? Are you talking about internal wiring? I'm not the right person to speak about this because that comes under a product standard. So you need to talk to the manufacturer of the product then. It is a very valid concern, but it doesn't come under electrical installations.
Hello. So we manufacture a lot of products which is anti-termite and anti-rodent. So as you said, there are a lot of rats which is biting the cable and then eat it, and there is a damage. So similar, some anti-rodent, antibiotic products is available where rat will go and then they will take the smell of the chemicals and they will not bite this one. So these products are available and many places it is going. In spite of that, suppose if you feel after 4 years or 5 years, sometimes a lot of customers, they feel that this effect is not there. So in that cases, we give a polyamide coating over that and rat is not coming over there and it will not damage over there. So you can take our brochure and you can see this one. Yeah, it is done. Home appliance manufacturer like LG, Samsung, then Dixon's. So it has provided, but again coming the cost, because when you use this kind of product, the cost is going up. So India is a cost conscious people. So things sometimes may not happen. So I accept your proposal. Definitely we'll once again propose them. Yeah, thank you.
Right. So now you've got solar and UV radiation. A lot of you guys, I'm sure, have worked with transformers, and you can see this is what happens when a cable not rated for UV is exposed to the sunlight or any other UV radiation. The insulation is completely cracked, and the cable is completely rendered unusable. So how do you protect against this? Usually materials like PA12 are tested for a certain amount of UV resistance, especially for sunlight. Just use cables that are covered in PA12 or conduit that is covered in PA12. Manufacturers that make this are there. I'm sure Polycab also has UV resistant cables. Now, if there are other sources of UV radiation that pertain to particular manufacturing processes, then shielding or other measures are required, and obviously you will need to consult with the client and manufacturer. That is outside the scope of 732 and SP30. Another important thing is, like I said, when sunlight or UV radiation is present, this will have one effect on the insulation, but it will also have an effect on increasing the operating temperature. So derating is required. Now, what factors are these? Let's look into this a little further on. Seismic effects. Now, if you're in an area that is especially prone to earthquakes, you need to get a risk assessment strategy made, especially with people that are experienced to deal with seismic effects. Then you need to take that risk assessment strategy, talk to your M&E manufacturers, wiring system manufacturers, and your clients, and devise a strategy. Now, a lot of you might say this is impractical, but like Mr. Apavo correctly said, you're investing a lot of money. You might as well get all the data together. Also, it's worth looking at the sections for vibration and impact. Air, if you've got windy areas where this sort of a situation is going to happen, you need to again ensure that your systems are not prone to damage. You can look at vibration and other mechanical stresses for this. Now, if your stored up processed materials are especially flammable, then there's an entirely different section of IS 732 and SP30. In IS 732 to section 4.3, you can use specialist equipment like AFDDs, or you have to maintain a clearance, or you may even have to go in for shielding. Same thing for building design. If it's a wooden cabin, etc., then again special equipment, clearances, and shielding come into picture. Does anybody have any questions about the protection to external influences? Now is a good time. Okay, so if anybody doesn't, so we're going to take a break right now, and after that we look at the other sections, and I believe a sponsor is also going to speak in between. Thank you.
Wiring and protective devices, we'll have Mr. Krish on the dais to proceed.
Hi, if you could please take your seats. We'll be looking at cable sizing, going through some mock calculations as well, and we'll even delve into harmonics a bit. So if you could please take your seats.
Hello, kindly take your seats, please. Hello, the session is starting. Kindly take your seats.
Okay, so let's begin. So for cable sizing, there are 13 basic things that I want to cover. One is the current carrying capacities, how these are achieved. Then you have tabulated current carrying capacities is what the manufacturer and the standard will give you. And these are usually based on your cable maximum operating temperatures. Some loads, as you know, require protection against overloads, some don't, most do. Then you get a tabulated current carrying capacity from your cable manufacturer. How do you actually derate this to the in-service current carrying capacity for continuous load? We're going to look at that, because as you know, all these external influences are going to be present. So you need to derate what the manufacturer gives you. These factors are basically IS 732 looks at grouping, and even NEC, the ambient temperature, soil thermal resistivity, and there is a ninth one called fusing. The fusing as a factor is not mentioned in 732, but reference is made. We'll get to that. We will do a sample cable calculation. So please, I believe they have given out a kit with a pen, pencil, or pen, and all of you have a calculator on your phone. It is a very simple calculation. I would appreciate it if you follow along. And you know, more than anything, it's difficult to remember everything because the code is there. But if there's one thing you want to take back from this presentation today, it is how to derate. So if you just follow along this calculation, it will go a great deal further in helping you derate cables, which is a fundamental requirement of the National Electric Code and IS 732. We'll also look at neutral conductors and harmonics and how these are affected. And the last thing is voltage drop. So let's get into it. So when a manufacturer comes up with current carrying capacity, there are basically a bunch of factors that they look at. But even when they give you a current carrying capacity table, and we look at an example from Polycal later on, this is based on the type of insulation, and they give you multiple values, and you have to select it based on the type of insulation. Is it XLP, PVC, and what the conductor maximum operating temperature is. How the cable is installed, because you install a cable clipped on the wall or in free air versus you have a cable in an underground duct, the current carrying capacities for these cables are going to be completely different simply because of the heat dissipation possible that is available. There are derating factors mentioned for all these grouping, soil thermal resistivity, etc. There are in Annex S. So if you've got 732, please open up Annex S, and if you've got NEC, go to the end of part 1, section 9. There will be a bunch of tables. Please open that so you can follow through with me. Also, you got to look at harmonic content. Like I said, 4-core cable is only rated for 3 loaded cores. Any more loaded cores, and then you will need to derate. And if the loads are resistive, inductive, or capacitive, this will have some effect. Obviously, when your 3 phases combine in neutral, this is out of the scope of 732, but just keep this in mind. So when we look at tabulated current carrying capacity, and I'll blow this table up later on for the actual calculation, you see it gives you the cross-sectional area and the different installation methods defined. So to choose it, you need to see what is the cross-sectional area. Firstly, is it copper or aluminum? What is the installation method? And what is the ambient temperature? The ambient temperature, like I said, is for 30 degrees in air and 20 degrees in ground. That is important because that is on the basis of that you have to perform a correction. And whatever the conductor of maximum operating temperature, is it 90 or 70? Now this is an interesting thing about 90 and 70 degree conductors is if you look at table 8 from IS 732, current carrying capacities are determined on the basis of what temperature the cable insulation can withstand under constant loading. We all know this. But see, if you look at note, this third point here, it says, second point, it says basically what it says, is if a 90 degree cable is being used and the equipment that you are connecting to the 90 degree cables, the terminals of that equipment are only rated to perform at 70 degrees or a lower temperature, or it is unknown, you cannot use the 90 degree rating of the current carrying capacity of the cable. You have to look at the 70 degree current carrying capacity, because obviously we know that as the cable carries more current, it heats up. Granted, the insulation in 90 degree cables can handle up to 90 degrees, but can the terminals, can the equipment handle? If we do not know, then we have to derate. So now protection against overload current, and this is the bit where we look at protective devices. There are 2 basic things in IS 732. You can refer to section 4.4 as well as clause 5.2.6 in section 5.2. So the first important thing, and this is not mentioned in 732, but it is very important, is that a circuit shall be designed such that small overloads of long durations do not occur. This is very important because, see, a circuit breaker does not trip the moment the current is exceed. It has a tripping curve. But if you have a small overload that exists for a long time, your cable will reach a sustained temperature greater than what it is rated to handle, and then that will cause damage and potentially fires. Now, how do you coordinate the conductor's loads and overcurrents? It's a very simple formula. The design current of the circuit shall be lesser than the amount of the circuit, the rating of the circuit breaker, which shall be lesser than or equal to the amount of the current carrying capacity of the cable. So if you have a, let's say a 14 amp load, you can use a 16 amp circuit breaker and a 21 amp cable. That way we maintain a clear distinction between what the cable can handle, what the circuit breaker trips at, what the nominal rating is, and what the load will produce. Then this is a very important thing which is not exactly talked about a lot. I think Mr. Appavu had made a very interesting spreadsheet for this, which is why I delved into this deeper and started talking to people about it. See, there is something called I2, which is defined in all the product standards for overcurrent protected devices. This is what current the circuit breaker will trip at a given time for overload. We're not talking about your BCDs, overcurrent, short circuit or fault trippings. We're talking about in an overload what the circuit breakers will trip at. This value has to be lesser than or equal to 1.45 times IZ. And IZ is the current carrying capacity of the conductor for continuous service, which is derated. How we get the derated, let's look at now. So the very simple formula is the derated value is a tabulated current carrying capacity multiplied by the grouping factor, multiplied by the ambient temperature correction factor, multiplied by the soil thermal resistivity factor, multiplied by the fusing factor. It's a very simple multiplication. See, these values are in either are usually less than 1. So if you take the current carrying capacity and you multiply it by a value less than 1, you will get a smaller value. That is how the duration works. So, and this is the IT is either from the manufacturer or from Annex S. And like I mentioned, these are the grouping factors. Now the fusing factor is an interesting factor because, as I mentioned previously, this regulation has to be complied with. Now, if you assume a worst case scenario where IZ is equal to IN, the IN is going to be what we have to consider for the fusing. So if I2 has to be lesser than or equal to 1.45 times IN, any circuit breaker or overcurrent protection device, mainly these are fuses where this issue happens, that has a fusing factor greater than 1.45, we need to then apply a correction factor. How we'll get into. So grouping, firstly, like I said, multiple circuits together, increased heat is much more difficult for the heat to dissipate. But please note, the grouping factors only have to be applied for cables that are loaded to more than 30%. Because if the cables are not loaded to more than 30%, there is no appreciable thermal strain that is going to have an effect on the other cables. But now you might say that a socket circuit will have barely any load, so we can say less than 30%. That is not true, because a socket circuit is open-ended. You can connect any device, any appliance. Only when you know that a circuit cannot go above a certain load under normal conditions, such as a lighting circuit with only lighting connected to it, then can you apply this. Then can you not consider grouping. Also, these factors are for equally loaded cables. For cables of different loadings, please refer to Annex S and IEC 60287. Now, ambient temperature. So again, what is the most onerous ambient temperature in the condition? If it gets cold in the winter and hot in the summer, you have to take the hotter temperature. Again, ambient temperature correction factors are different for the different types of insulation. PVC and XLPA will have a different correction factor, and mineral insulated cables will have a different correction factor. Also, so there's that. And the insulation reference method, of course. Is it in the air? This is a separate table for this is in air, separate table for in the soil. Again, soil thermal resistivity. If the cable is buried in the soil, IS 732 and SP30 only consider thermal resistivities up to 2.5 degree Kelvin per meters per watt. So this is quite important, because if we do a soil thermal resistivity study, usually these are given by area what a soil thermal resistivity is. If basically soil thermal resistivity is the ability of the soil to dissipate heat. If the soil has very high thermal resistance, the cable will be able to dissipate heat into the environment slower, hence the cable has to be derated. And also, the deeper you go, these change. So this table only covers buried depths up to 0.8. IEC 60287 goes further into this. Now the interesting one, fusing factor. See, this is a table that I have put together looking at all the various product standards as to what the tripping currents and the non-tripping currents are. See, for 60898 circuit breakers, it is 1.45. So most of the time people forget about that 1.45 because this is taken care of by default. But for HRC fuses, this is 1.6. And for KitKat fuses, your rewirable fuses, this is 1.9. So these will make a massive effect on the current carrying capacity of the cable. They have to be derated. So basically, how do you come up with these derating factors? See, you have to refer to the product manufacturing standard or ask the manufacturer for what the conventional tripping current is. So since we are allowing fusing currents which are up to 1.4 times IN, as per 4.4.1 or 732, anything with a fusing factor over 1.5 has to have a correction factor applied. How do you get this correction factor? Simple. You take 1.45 and you divide by the fusing factor. So if for KitKat fuses, 1.45 divided by 1.9 is approximately 0.75. For HRC fuses, it's 1.45 times divided by 1.6, so 0.9, which means that if you are having a KitKat fuse, only 75% of that cable's current carrying capacity can be used, and if it's an HRC fuse, only 0.9% of the current carrying capacity can be used. Okay, now I really encourage you to follow along. This is a sample question. All you need to do is, I'll give you the formula, I'll show you the tables enlarged, just select a value and multiply them as per the formula. Is everybody clear on this? Okay. So let's just rearrange the formula firstly a little bit and let's make a couple assumptions. This is our original formula. Let's assume that worst case scenario, the IZ is equal to 16 amps, which is the rating of the cable. Let's just look at the question now. A 90-degree XLP cable complying to IS 7098 has to be buried in an underground duct at a depth of 0.7 meters. The surrounding soil has a thermal resistivity of 6 degree Kelvin per meter, 6 degree Kelvin meters per watt. The cable is laid along with 3 other cables which are equally loaded. The ambient temperature of the soil is 40 degrees and the cable will be protected by a 16 amp IS2086, which is a KitKat rewirable fuse. What is the minimum cross-sectional area of cable that can be used? So like I said, we'll rearrange the formula a little bit. If everybody could take a picture of this or if they remember, great. I'll show you the values now. This is the value, the table for grouping. I'll give you 30 seconds. Please decide what rating factor you want to use. Remember, 3 other circuits. Okay? So if it's 3 other circuits, we're going. Has anybody thought of a value first, please? Nobody? Come on, I must be a really bad speaker for none of you to follow along. Anybody? Okay, maybe a little encouragement. So if 3 other loaded circuits are there, you have to use for 4 because that's the 4th one. How is it installed? It is method A to F because method D is for embedded or enclosed inner underground duct. So we'll use 0.65. So we'll just plug in CG as 0.65. Now, ground temperature. Come on, this one is really easy. By the way, even though it is 90-degree cable, we will assume that we only can use the current carrying capacity to 70 degree because we don't know the equipment limiting temperature. So then we've got PVC. This is a really easy one. I do expect somebody to give an answer for this, please. Thank you. So we'll plug in 0.77. Now thermal resistivity, again, really easy one. Anybody? Thank you. So we plug in 0.96. Now KitKat fuses, anybody remembers the correction factor for fusing? Thank you. And where did I get this factor? I didn't pull it out of my hair. See, if you look at regulation 4.4 at IS 2086, it refers to the manufacturing standard for the fuse wire, which is 9926. This mentions a non-fusing current of 1.6 and a fusing current of 1.9 times I delta IN with a 30-minute conventional trip time. So we plug in 0.75 and you get a cable that needs to carry more than 44.41 amps. So do you see how for a 16 amp protective device, a correctly sized cable as per the regulations has to carry 44.41 amps. Massive difference. You might say 16 amp cable, let's use 2.5 square millimeters. No, you need to consider all these factors. Now this is an easy one. The method is D1. Please, you know the current carrying capacity. What size of cable can be used? Minimum. That's right, 6 square millimeters. 10, somebody said 10 is also fine. It gives you a greater, 6 is correct. So we know 70 degrees is the maximum assumed because we a lack of other information, therefore a 6 millimeter cable is to be selected. Congratulations, you have done one of the most fundamental things in electrical safety design. I hope you take this forward when you do your actual projects. Now neutral conductors. How many of you guys have seen a 3.5 core cable? Heard of them at least? They're very common. People say neutral doesn't carry any current, let's use 3.5 core cable. The truth is, maybe. In a lot of foreign countries, these are being phased out now. So where can you use a reduced cross-sectional area for neutral? See, you absolutely cannot do it if it is a single phase circuit because the return current is, the neutral current is going to be the same as the line current. If it is a polyphase circuit where the cores are not very big, say 16 square mm copper or 25 square mm aluminum, if they are lower than this, then there is no scope of this as well. And if there are triple harmonics, which to be honest are most loads, especially triple harmonics greater than 15%, then you may not. Where can you do this? If the neutral current including harmonics is lesser than the current carrying capacity of the neutral conductor. But bear in mind, if this is the case, you need to derate for 4 loaded cores. As per 60287, the rating factor is 0.86. So only 86% of the current carrying capacity can be used. Now, this is there. And it's very important, if you do use this reduced cross-sectional area neutral, you need to have a 4-pole protected device, and the 4th pole has to be rated accordingly. Remember IB, IN, IZ, you need to perform that calculation specifically for the neutral conductor. So a lot of devices, I know Hager and Eaton have protected devices where the 4th pole on the neutral allows you to set a reduced current for the tripping of just the neutral conductor, because this will only trip when the neutral conductor currents go over the current carrying capacity of the neutral conductor. Now harmonics. See, very often we are told that harmonics have an effect. The truth is that the significant one is third and odd multiples of the third harmonics, because these sum are neutral. Let me just go into this a little more. Sorry. See, when you have non-linear loads, basically electronic control and power supply units, their waveforms are not sinusoidal. And what happens is you have a further waveform that is superimposed, which is in multiples of the fundamental frequency. The fundamental frequency we all know is 50 Hertz. So this may be in multiples. So this say is happening. You can see this is is going through the full cycle. I think in this case, little more. It's definitely more than 2 times the fundamental frequency. So these now, if I have this in the red phase, this in the yellow phase, this in the blue phase, see what happens? The 3 phases cancel out. But what is happening in the neutral? It's conducting. And when you take the root mean square of this, you're getting a current. This has to be considered. Now, how do you consider this? See, usually equipment manufacturers will give you a THD percentage for their loads. So depending on the load, you will get a THD percentage. Now, because it's triple in harmonics, we just need to multiply the it by 3. So if let's say if the 15%, if it's 0 to 15%, then on a 100 amp load, then all we need to do is do 3 times 15 times IBL, which is 45 amperes. So that is going to be the neutral current. And in, let's say, up to 15%, we do not need to worry about making any additional allowances for the harmonics, because this is way within the current carrying capacity of the neutral. But this is where it starts getting interesting. See, if you have 15 to 33% triplet harmonics, then 45 to 99 amps. And see, you're reaching 99 amps for a 100 amp rated circuit. So then deration is required. All you do is you take the line current and you derate by 0.86, so 116 amps. Now, the neutral is going to carry 116 amps, where your line conductors are carrying 100 amps. So then you need to choose a cable rated for 116 amps. When you start seeing triplet harmonic distortion over 33%, then you can no longer base your current carrying capacities on the line conductor. The IZ value that we chose has to be the neutral conductor load. How do we calculate that? Again, times 3. So if it's 33%, 99. If it's 45%, 135. And times 3 multiplied by 100. And again, you have to apply a 0.86 factor. Now, when you have greater than 45% triplet harmonic distortion, There is no 0.86 factor applied. Can anybody think of why? Why is it that in a more onerous situation, technically more onerous situation, we are not applying a derating factor? Anybody? Okay, I'll give you the reason. It's because the neutral and the phases are going to be so oversized for the line conductors that the line conductor operating temperature is going to be nowhere near your neutral, near the maximum. Therefore, the effect of the heating can be not considered. And this is table 45 from IS 732, and it is also there in part 1, section 9 of NEC, clause 5.6.5, which shows these exact factors. All I have done is got a table that shows it to you nicely from an IET design guide. Now let's perform a simple triplet harmonics calculation, basic third grade multiplication. A 250 amp 3-phase load produces triplet harmonics of 40%. What 70-degree multi-core cable can be selected considering no further rating factors from table 23? Okay, so everybody remember the formula. You just do 3 times the harmonic distortion and you multiply it by the load current. So if you can pull out your phones, or if you're good with mental math, let's go. So this is the table, by the way. So have you done the calculation? Have any of you done the calculation? I'll show the question again. 40% triplet harmonic distortion, 250 amperes. Anybody? What's the current going to be in the neutral? Come on, simple math. You want me to break it down for you? I think some people are working on it on their phones. How many amps does the cable have to carry? 300, thank you. So what's the cable we're going to choose? Installation method, what was the installation method? C. What is the cable that we'll choose? Thank you. Could you choose 150? It's close, right? Could we? Yes, no? Thank you. So yeah, just do 300 by 0.86. So, now you all forgot about something. What happened to the derating factor? 300 amps is the current, correct? But how many loaded conductors do we have? We have 4. So, we need to do a further deration. So, actually, we need a 240 amp cable, 240 square millimeter cable, because the 0.86 factor kicks in. So any further guidance on harmonics? You see, obviously harmonics are a big topic. They affect the cable ratings and overcurrent protection, but they also affect voltage drop. So there's a formula here from the IET design guide. This is obviously beyond the scope of 732 and SP30. So if you want, you can look at this. Usually software does this for you, and they will also affect equipment functioning. Now harmonics of the 5th and 7th, in multiples of the 5th and 7th frequency will also affect the line current. So you have to also choose a current carrying capacity that is derated. Again, this is beyond the scope of IS 732 and SP30. There are IEC standards for this. If you get no information from a supplier of the equipment on what the triplet harmonics content is, this is what you can assume. And remember, this is a general rule of thumb in absence of any information. 70 degree for televisions, computers and printers. So any circuits with this, you need to obviously do duration. If you have fluorescent lights, 30%. If you have variable speed drives, 15%. Now voltage drop is a very simple thing. The cables and conductors that we have going from our source to our loads do have some impedance. And as a result of it, some voltage will be lost. What we need to make sure is that the voltage that at the terminals of the equipment is not below the voltage required by the equipment for its safe functioning. And if this is not provided by so usually, equipment will say 200 to 240 volts, or 200 to 250 volt is their range. If that information is not provided, then there's a simple thing as per table 47 of IS 732. If it's a public LV supply, you're allowed 3%. If it's any other use for lighting, and if it's any other use like power, you're allowed 5%. If it is a private LV supply, 6%, 8%. Remember, for 3-phase loads, the voltage drop is different. You have to do 400 or 415 volts times 3% or 5%. See, in a private supply, you have a very, the voltage, in a public supply, if you notice, the transformers are actually rated for 433 volts at the output. In a public supply, you might not have that. It might be putting 415 or such, which is why you make a greater allowance for voltage drop in a three-phase system. It is purely an equipment based thing. It should be uniform. See, at the end of the day, what matters is what the product needs to function. Only in absence of that information, we are going to look at this table. Any questions about cable sizings? Then we'll come to the topic of terminations. Out of the scope of 732, I'm not the right person. Any other questions? Okay. So terminations are an interesting subject because of the next image. So what do we, so this is breaking down, I'm going to break this down into what factors we consider for choosing the correct termination. When you have connections and terminations, what different technologies are available. Class 5 and class 6 conductors, very debated topic, and glands and cable entries. Now, how many of you have seen a tape jointed? If there's one person that hasn't raised their hand, please, I want to know where you have seen a cable jointed properly. You've seen a cable jointed properly? Or you have? Well, then you're one of the very few people that has actually seen one. See, very often proper joints like this in low voltage final circuits are not done. It is just somebody that twists and bends and puts it together. How do we decide what connection, what gland to use? Is the conductor material and insulation. See, if it's a 90-degree cable, then the connector has to be rated. Now, I know Vago makes connectors that can take cables up to 105 degrees. So that is adequate. What is the kind of wire? Is it class 5? Is it class 2? Is it class 1? Even class 6 maybe? What is the cross-sectional area? You cannot shove a bigger cable into a termination that is not suitable for that. If you're doing parallel connections, how many parallel connections can it handle? Conductor emitted temperature will be correct. And locking arrangements, it needs to be robust for the environment. It should not just come out and the cable should not be loose. Now, how that is, we'll get into. See, when connections are made, appropriate terminals need to be used, and these need to conform with their product standards. Like I said, to meet the performance requirements of 732 and NEC, you need to use products that conform to certain other product standards, so you can meet the overall product standard of performance. If you're using a terminal block, it has to comply with 60947-7, the requirements of. Screw terminals like the ones we saw earlier need to comply with 60998-1 and 60998-2-1. 60998 is for connecting assemblies, 2-1 is for screws. Clamping or cage terminal types like the Vago one has same standard 60998 part 1, but it for the specific to a clamping or cage clamp is part 2 subpart 2. And if you have a screw terminal, right, you need to make sure that the termination is done with a calibrated torque wrench or screwdriver like shown in the image. A very big problem, like somebody mentioned yesterday, is loose connections. But so okay, you tighten it up, but something I want to talk about that is not very well known is over tightened connections. If you over tighten a connection, the force on the conductor will cause the conductor to snap, or worse, the terminal block to break. Then it will affect even other conductors. So please use a calibrated screwdriver. There are a lot of manufacturers that make this. It is a very common tool. And all these circuit breakers, right, even MCBs, even all these connecting devices will all say tightening torque 2 Newton meters, 1.2 Newton meters, whatever. Please follow these. Without doing this, all the money spent on your equipment is useless. Now, connection assemblies are an interesting topic because you cannot make a connection and just put it anywhere. See, firstly, the connection assembly has to be suitable for the external influences. And certain connection assemblies are only suitable for certain connection devices and vice versa. In the case of Vago terminals, if you want to achieve a maintenance-free status, then you need to use it with a junction box that it is certified by. So two brands, Vago and Visca, have actually certified their junction box and connectors for use each other. I was going to get a sample to show you, but getting that sample through airport security would have been a bit of a problem. Sorry? So now let's look at, again, 60670 part 22 is for connecting assemblies. So we'll look at that. That is what the product that you need to look at. Strain relief devices are important because say there is a strain on this cable, what is going to happen is the termination is going to get strained. So strain release devices, sometimes they are built inside glands, sometimes they are not, need to be so that at the end of the day, when there's a strain on the cable, the termination is not affected. Obviously, the cable has to be built to withstand that strain. Now, very big thing in India is the use of class 5 conductors, 6 not so much. See, which is your flexible cables, they shall not be used for fixed wiring unless they are, and only unless they are required to, simply due to their application. And if they are used, you need to take precautions. One thing is you need to use a different current carrying capacity, like Mr. Gopakumar always says. Second thing is, when you put a flexible or fine stranded cable in a conductor, the cable, when there is force, will spread. Then you are not getting all the cross-sectional area. You are only getting some of the cross-sectional area, and that results in a hot point. How do you deal with this? If it is an MCB, if it is in a light switch or a socket, you need to use ferrules. Unfortunately, no IS or IEC standard exists for these ferrules. There are DIN standards, DIN 46228, and for these ferrules. You can get these in the market very easily. I believe even Dowell's, which is a Polycap brand, makes these ferrules. If it is in a terminal, a screw terminal, you need a lug, and again the lug has to be crimped with the proper crimping tool, and the lug has to be rated for use with class 5 or class 6 conductors. Or in the case of Vago connectors or cage clamp connectors, now these are simply rated for class 5 or class 6 cables, so then no further precautions need to be taken. Cable entries, there was a gentleman that asked, have any of you all seen this tape joint on armored cable? Pathetic. This was in my own office. Before I got possession of the building, this was the gland. Or needless to say, I replaced it with a proper gland. There is an IEC stand for metric threaded glands, but there is no IEC stand for the steel wire armor cables. BS6121 is there. A lot of manufacturers refer to that, make their products to that. There's also an EN standard for this. But see, generally speaking, 62444 is a good idea because it is metric threaded. But obviously, for steel wire armor, special glands need to be used, like 6121. Any reviews on connections and terminations? Any questions? Sorry? Yes. Yes. See, I can get back to you on this, but see, are you talking about washers on lugs and screw terminals?
No.
Oh, yeah. Then you need to, see, I can find out the product standard for it, but importantly, if it is not built for that electrolytic corrosion, then the antioxidant has to be used. Product standard, I'll get back to you. Okay, so mainly fire safety has already been covered by Mr. Gopakumar, the performance requirements of the cables. I'll just talk about premature collapse a little bit. See, basically, you cannot use plastic trunking and plastic fixings for cables in areas like these, because when in a fire condition, all this will collapse. There was a very famous incident in the UK called the Shirley Tower incident. You can see in front of the doorways what has happened. They used plastic fixings and all the cables came down. Now in a smoke-filled environment, you will not see this. This thing is piping hot, you will get burnt. So what should you do? Use a cable cleat that complies with 61914, a steel cable cleat. More importantly, cable cleats are still used. The nuts, bolts, anchors, screw systems, everything has to comply with the product standard. There are EN standards for these. And everything has to be made of non-combustible material. Remember, this is for areas that require this. If you just do a simple cable on a wall for a light, then this is not required. But if anything is overhead and it is going to come down, then this is required. Fixings like saddles on screws on plastic walls and anchors just do not satisfy this requirement because they will melt. This is a big change that is required. Fire-rated cables can be used, mineral insulated cables. I won't go into the standards because it's already covered. I'll just show you an image of, this is a cable that is rated to these standards. And you see there is no smoke produced, there's very low smoke produced in a fire. But this is what happens in a cable that does not comply with these requirements. Additionally, if cables are not fire rated or fire performance, a simple flame propagation test can be performed on, if the cables are comply with the requirements of the simple flame propagation test, the vertical flame propagation test, you can simply put the cable in a non-flame propagating enclosure, or such as trunking or conduit. Remember, again, it has to be conducted of non-flame propagating material as per the relevant manufacturing standard. Fire sealing we covered, like Mr. Gopakumar mentioned yesterday. See, there is currently no IEC standard for fire sealants, and frankly speaking, requiring a need for and identifying a need for fire sealing is the job of an electrical consultant, but doing the actual fire seal is not the job of an electrical consultant. I spoke with a gentleman in the UK. He is on the IC committee. He is very involved with fire sealing. He told me, Krish, frankly, this is not an electrician's job. You need to call specialists. See, basically, how do you ensure a proper seal? I've tried it myself, okay? I've bought a fire sealant from Fisher, and I've tried making a fire seal with a silicone gun. I have experiences using silicone in bathrooms for water sealing, but I was unable to make a proper fire seal. And even if the seal is proper, the product has to be selected because A, it has to resist the flame and the products of combustion according to the same degree as the building element. It needs to have the same rating for the ingress of water and moisture. And like Mr. GK said yesterday, it should not have detrimental impact with the cable. Otherwise, you're going to have a degradation in insulation. And it also needs to allow thermal movement. When the cables get hot, they expand. When they're cold, they contract. And the mechanical damage due to a fire will also affect the fixings. The sealing, so if the fixings collapse or the fixings are weakened, the fire sealant should not break simply because of the weight of the cables coming there. Obviously not forever, for a rated time. Internal fire sealing is also an important thing because most containment measures like this have a cross-sectional area greater than 710 square millimeters. So internally also these have to be sealed, otherwise you seal from outside, great, the fire will spread from inside. There are exceptions to this. If the wiring system has a cross-sectional area lesser than 710 square millimeters, most conduit have a greater cross-sectional area, and the system is rated for IP33, and any terminations in that system are rated for IP33, only then can you not internally fire seal. So that's fire sealing. We're coming to the end of my presentation, so I'll just wrap up. Any questions for fire safety, fire sealing? Okay. Right. Mm-hmm. Yeah, so see, the thing is, these requirements are not set in stone in the regulations because there's no standard. It just says it may be complied. So any other products like the gentleman from Polycab is suggesting may, of course, be used as long as it meets the performance criteria. Sure. Please do. You can very easily write a comment on the current regulation. Contact BIS. I'm sure they'll be very receptive to you. Oh, yeah, probably on BIS also as Polycab. Thank you. Thank you. No, sure. Go ahead. Yeah. Yeah.
Especially used for this one, shaped conductor.
Shaped conductor, yes, because that's, yeah, like I said, the shape of the conductor is very important.
Shaped conductor, many times problem is that when you use the connector or lug, so 100% surface to surface touching is not there. So this is specifically developed for the shaped conductor and can be used successfully.
Yeah, that's a very good point because, you know, when I was looking at shaped conductors, and most armored cables are going to have shaped conductors, you cannot just use a traditional lug. Like he said, there's not going to be 100% surface to surface area conduction. So I know Dowell's has a product, and that's a good product for this.
Thank you.
I'm adding some more points on fire sealants. See, fire sealants, no, it is not only cable bunches. It is as a current carrying conductor with the cable tray also available. Moreover, no, fire sealants are available for the external wall and the ceiling as well as the internal partition wall. There are 5 types of fire sealant products are there actually. Depending upon the use, the intention actually, we can use that product. One more point actually, somebody asked me about this rad bite actually. Our fire sealant, especially ablative coating paint, no, it is not only fire protection paint, it is a material of chemical reactive product of polyol, polyether and isocyanide. It is not only fire resistant, it is anti-bite resistant also, rodent anti-bite resistant also. In addition to that, actually as far as passive fire protection concerned, see, for protecting the emergency escape route, as well as the emergency lighting, cable bandages are available. Then metallic duct is available. Then lightweight concrete ducts are available. These are all protecting the cable during fire accident. So many things are available. It will not affect the, actually its main intention is maintaining the structural integrity of the building.
Sir, if I
It
may,
is the main aim of the passive fire protection.
is there a question or?
It's not a question actually about the sealant, fire sealant you told me actually.
He is
Fire
only
sealant
adding
will
value.
affect
Information.
the shaky of these cables you told me actually. Different fire sealants are available. Fire products, passive fire products are available. It can able to retain the cable bunches there actually. We have called one product called Pyro Black. It can able, we will make a conduit.
Gentlemen, please note that we are talking about certain conditions which is shown on the slides, the conditions of the IS 732 or the NEC, and we are trying to explain what is written in the standard.
Very good.
We are not talking about how many type of fire sealants are there, how many coatings are there. That is not the subject. We are trying to, the program is about NEC, what is written in NEC, how to read it. That's it.
Very correct, sir.
Yeah.
Very correct.
Yeah.
One more thing actually, for passive
No, we
fire
have so
sealant,
many other subjects to continue, and if we keep on discussion like this, you know, it won't end up.
I'm just enlightening sir actually. One IS standard is
Correct, you
available.
can do
IS
it
1245
probably.
is
If
there.
anybody wanted to ask about fire sealant, please contact him and you can get the information, because, you know, let us not deviate from the subject. We are already late, almost 2 hours.
Right sir, right sir.
Thank you.
Right.
Okay, so just one thing. So these other considerations are mainly for proximity to other services, mainly with regards to EMI and stuff like that, and separation distances. So I won't go into that. Just two things here is that if you have cables near service shafts, like if you can, you know, many air conditioner companies, when they send their service people in the same taped system, they'll put their refrigerant pipes and their cables. What is going to happen? The refrigerant pipes will get cool, water will condense, and that will cause deterioration of the insulation. This cannot be done. You have to maintain adequate separation. Last thing is maintainability. See, wiring systems need to be designed for maintainability. They need to be designed robustly so that you can make additions, alterations, etc. Please keep this in mind. You're not just banging it in and putting it in. You need to make sure it serves its useful life, and maintenance and additions can be all done. If you want to read any more, just please take a picture. These are great publications for this, and thank you.